Hi, this is the vintage total air temperature indicator from Lockheed Control. So the total air temperature is a particular temperature which is measured in a particular location called the stagnation point where the airflow is zero. So from the total air temperature it is possible to calculate the outside temperature. The total air temperature is always above the outside temperature and the difference is called the ram rise. So generally the sensor is a platinum sensor, generally 500 ohms I think. This thing was repaired probably in 95. On the rear there is a connector and two adjustments, plus and minus. So first I will open this thing to see what is inside, and after, if possible, I will try to get it work. I think it can be interesting to test this thing. Okay. So on the front there is this motor. So this is an AC motor. You can see this capacitor, which is probably used to provide a phase shift of one winding, and probably there is a reduction gear incorporated to this motor. So this should be this assembly on the front here, and we should find also a potentiometer somewhere inside the motor. So this seems to be a servo control itself with the motor, the reduction gear and the potentiometer. On the electronic side there are two boards and a toroidal transformer in the middle here. It is a little bit loose. So we have on this board several accurate resistors, 0.5% for this one. I think they are more or less all at 0.5% tolerance. And there are several transistors, 2N4239. And we have an IC, so I don't know this reference, AD 3005. This is a very strange reference. Generally, the number has 3 digits, dead code 79. And this is maybe an op-amp. This one is a 741, and also 5 terminals only are connected. This seems to be a fuse. And on the second board, there are also several transistors. This seems to be a tantalum capacitor. So on that board there are only transistors, it seems. So I think that this board is the power supply here on the right, it is obvious, and probably the servo control amplifier here, at least maybe the output stage only. And this board is the front end for the platinum sensor. And we can see that the construction is very nice. It is possible to remove the boards easily. There is nothing to desolder. You just need to separate the connectors from the board. So thank you very much. And we can see the two trimmers here for the adjustments. I will do a quick reverse engineering of this front-end board. So probably it will be enough to make it work, otherwise I will do also the reverse engineering of the second board. It seems that we have a broken solder here. We can see that this part has been changed. This is this transistor. You can see that the fuse has been replaced also. You can see that the solderings of the fuse are not very clean. this is a schematic diagram of the front-end board, which is this one, and also a part of the power supply, which is on the second board with the toroidal transformer. So the power supply is on the bottom side of this page. There is a positive power supply and a negative one. It is a classic stabilized power supply. So the main interesting thing is the front end, which is on the top of this page. So this is interesting. Actually, we have two amplifier stages, one differential amplifier and another amplifier here. So the output goes to the servo control in order to set the pointer of this indicator. So let's have a look on the front end itself. It is interesting. This circuit permits to compensate the resistance of the wires between the sensor here and the indicator. So the sensor is represented here. This is a platinum 500 ohms sensor. The sensor itself is connected between terminal 21 here and the ground. And there is another connection at pin 20, which is connected actually to the ground of the sensor. So this permits effectively the compensation of the resistances of the wires, which are represented here. So the resistance in series should be compensated. So we can see that if this resistor is adjusted in order to have the same resistance than the resistance of the sensor, then the voltage will be 0 here. So this permits effectively to compensate the resistance, but this works at only one temperature. So there is something interesting is the value of this resistor, which is 352 ohms. And in series with this resistor, there is a trimmer of 22 ohms. If we take a look on the table of the platinum sensor of 500 ohms, we can see that for a temperature of minus 70 degrees, which is the minimum scale of this instrument, the resistance is 361 ohms, 62, and we can see that this is exactly the value of this resistor plus the mid scale of this trimmer. So effectively, this is a low adjustment. This permits to have 0 volt at the output when the temperature is minus 70 degrees. So this is the adjustment of the low scale, and the high scale is adjusted by the gain of the final amplifier here. So this amplifier actually should have a good performance in terms of offset drift, etc. So this is why they have used a particular op-amp. I didn't find any information on internet regarding this AD3005. It is totally unknown. I will reassemble everything because for the moment the instrument is in kit form, and after that it should be possible to perform some tests on this device. I have connected this total air temperature indicator to a resistor decad box here. The resistance is set to 500 ohms. I have connected also this instrument to 115 volts power supply, which is just on the left here, this small module. Let's turn on the power supply. The resistance is currently 500 ohms, and you can see that we don't have the correct temperature. We should have normally 0 degree, and we have 35 or something like that. So let's try the minimum temperature. The resistance should be 362 ohms. Okay, we can see that we have the correct temperature. I can change 1 ohm more and less, so we can see that it is exactly 362 ohms. The adjustment of the 0 is perfect, but it seems that there is a problem with the adjustment of the gain of the amplifier or the servo control loop. We can search for the resistance, which permits to have 0 degree, for example. Okay, it is 448 ohms. You can search for the maximum resistance. Maximum resistance is 560 ohms. this instrument seems working, but I don't know if this is a problem of the probe itself, because normally it is a platinum sensor and the minimum temperature is perfect. Anyway, thanks for watching and see you next time. Bye bye.